So Sunday, our little cousin, she texts me.
Yeah.
She's like, I need.
Yeah, because when I was driving home, I saw your truck at their house.
Yeah, she texts me, and she's like, I need help with my chemistry homework. Let me pull up what she asked. And I completely misunderstood because I was thinking like way more advanced than what a little 11th grader should be being taught. So she said,
it's gonna be basic.
Huh?
It's gonna be basic.
Yeah, I wasn't thinking basic.
Mm.
So she asked, which substance can be decomposed by chemical means? Calcium, argon, sodium chloride, aluminum.
Mm-hmm.
Well, I was thinking, what are those? The least stable ones on there are calcium and aluminum. So I was like, calcium, aluminum. She's like, which of those two? I can only have one answer. I'm like, what the hell do you mean you can only have one answer?
Wait. Did you say, was it calcium carbonate? Or
sodium chloride.
Sodium chloride.
I was like, well, sodium chloride, the only way I thought of right away, I did actually think of a way to chemically break it down. But, it was electrolysis. I was like, that's not chemical.
Yeah.
But I realized this is an 11th grader. This is their first month of chemistry. This is not what the question is asking. The question is asking, which of these is a freaking compound?
Yes.
Not which of the...
which is why my mind immediately jumped to sodium chloride.
Right. Which I then realized, oh, shit, I'm an idiot. No, it's sodium chloride. It's salt. Don't worry about it. Don't worry about what I was thinking beforehand.
Yeah.
Well, so then she calls as I'm just finishing at Grandma's, and she's like, she's asking me more questions and stuff, and then she's like, can you just stop at my house? And I'm like, well, I'm basically there. So I stopped, and she was doing the review for a test, which was Tuesday. She has block scheduling now, so she doesn't have class till Tuesday. So she didn't have, this teacher, he's a piece of shit. He assigns a study guide for a test, and then isn't going to give them time to study the study guide. Which I thought was insane. He's going to go over it right before the test, and then that's it. He's not going to give them an extra day. I'm like, what is the... I'm like...
So they're going to go over it and then take the test?
Yeah.
Yeah, that's not usually how that works.
I'm like, that's a dick move. And then also, this question is horrible. This is a horrible question. Because think about it this way, right? This question it's relying on the idea that these kids...
No. I mean, I see where you're coming from.
No. My confusion, no. It actually has nothing to do with my confusion. It was with her confusion, actually, with the question. And that she had one similar to it that she didn't know how to answer, and she had to go to the teacher. And then the teacher just had to give her...
That?
Huh?
Which one was that?
It was the same one. It was asking which of these is a compound, or which of these is not an element, or whatever.
Uh-huh.
And so, my problem with the question is, all that question is saying, please look at the periodic table and figure out which one of these is not on there, and then that's your answer. Because unless you have prior chemistry knowledge, like you and I did in that class, or your prior teachers did better at teaching you. Fun fact, I actually realized it was her prior teacher that didn't teach her a damn thing in 9th grade.
I didn't really have much prior. I think I just had a good teacher because I didn't really know much chemistry stuff going in. The only stuff I really knew was anything, not even physics related. No. Because my physics knowledge pretty much came from senior year.
Yeah, well... So I
was just another naive little 11th grader taking classes that happened to have a good teacher.
Right. So you would have been one of the kids in the class, the smarter kids in my class who I'm sitting there, right? let's imagine 11th grade me had seen that question. 11th grade me would have been like, okay, it's salt, it's done, moved on. Wouldn't have even thought about it. Would have just been like, yep, it's salt, done, moving on. Okay. I might have done the same problem. Like, what do you mean by chemically decompose? Because when I hear chemically decompose, I'm thinking, okay, this can react with something, and the only option.
No, well, I was think when you said chemically decompose, I was thinking like broken down. I was like breaking down an element, like what, like a bomb? What do you mean broken down?
So that's what they mean. So that's what they actually mean. But when and that's what he means, and that's the way that's the way you probably should look at it. But when I think of it, I'm thinking
obviously that's easy. It's always you're gonna need a bomb to break down argon.
Yeah, well, see, they're talking on an atomic, molecular and atomic level. I'm thinking at a physical level. Can I dissolve a chunk of calcium? Duh, it'll break down in water. It'll break down in freaking oxygen. It'll just break down in air. Aluminum. That's a bit more difficult, but yeah, I can break that down. Salt, you just drop it in water. Okay?
Hold up. Calcium, for example. Is it correct to say that it's breaking down? Oh, I guess physically it's getting smaller, but the salt is not turning into a new element. It's still salt. It's just dissolved in water.
Right. Under what he... yes. Yes, so you're right.
It's physically getting smaller, but it's still the same element.
You're right. Which is where the confusion was coming from with me. I was thinking physically, not atomically, molecularly.
Yeah.
Which is where the problem was coming from.
Well, I think the reason why,
had he not put argon on there, had he not put argon on there and put like sodium, I would have just picked sodium chloride. Mm-hmm. I'd been like, I would have pieced that together. It was the argon that threw me for a loop.
See, I think what he should have done, though, is that, when I took chemistry, the first thing we did, though, if I recall, was learn the elements and all their symbols. Because there's 118 goddamn, symbols, and for a little 11th grader that doesn't know the periodic table, to have to go through each. Now, I guess you could immediately shortcut it and look like, oh, there's 2 capital letters. That's 2 elements. I mean, that's a shortcut way to look at.
And that's what he needed to do, because.
But when I learned chemistry, they taught us all the elements first. That way, you could know instinctively, oh, this is what all the elements were, without even having to look at the periodic table to know what the letters were.
Well, this wasn't. These were written out.
What?
These were written out, so you're going to have to look at the periodic table regardless.
Well, then they went from elements then to basic compounds and stuff.
Yeah.
And they taught me
that's what I would have preferred. I would have preferred that this teacher would have gone and been like, okay, and then written that question that way. Had done it with atomic symbols instead of their names. Because now, right, let's say you
can look at shortcut. Oh, there's 2 capital letters. That's a compound.
Right. And I feel like you're learning. Now, all they have to do, now, if they don't know how nomenclature works, because that you haven't taught that yet, that's not for another unit or 2, they're not going to know. And so now, they're just going to go look at the periodic table for 10 minutes. To answer the question. Like, that's dumb.
Yeah.
That's so dumb. Because, like, she had one where it was, like, name the compound, which one's a mixture or whatever, and it had, like, brass on there. And it was, like, brass and some elements. It's like, name the mixture.
Is it copper and zinc, or is it bronze?
It's, that's bronze. No, sorry, sorry. It was actually bronze. I said brass. My bad. It was actually bronze. Which is just copper and tin, but
copper and tin.
Yeah, but
copper
brass.
And zinc is brass.
Yes.
One of them was copper and zinc.
Copper and zinc is brass. I think. Because they call hold on, let me. No. Bronze is tin. Bronze is tin. I know that for a fact. But they must it must be manganese brass U.S. dollar coins are made of. Copper-plated zinc. Yeah, it's manganese brass. Okay, yeah. I thought it said manganese bronze. No, it's manganese brass. That makes more sense.
Is what dollar coins are?
Yeah, they're manganese brass. It's copper-plated zinc with Sorry, no, that's the penny. No, it's manganese brass. It's 85% copper, 6% zinc, 3.5% manganese. Wow, that is a lot of manganese. Holy shit. That is a lot. Fuck. Anyways, what was I getting at? So yeah, no, I was so upset with that question. I was like, this is a stupid fucking question. Like,
I think the first thing you teach is what the hell is mixture? What the hell is just the definition of a compound? You know.
Right. Well, and that's our cousin's fault. She wasn't doing a very good job with her vocab. And then there was a question.
Oh, so they did teach that. She was with vocab.
Yeah. Then there was a question. That broke my brain.
You had a horse? Oh, broke your brain.
Question was, which of these is a homogeneous mixture?
Oh, I love that word. Homogeneous.
Okay. So here were the options. Salt, water, iron, and like copper.
I'm thinking water.
That is the correct answer.
Yeah.
But it doesn't. But why? That's not a mixture. Water's a compound. That is a pure substance. What are you?
All the bonds are the same. Salt water is not. All the bonds are not salt and water.
So, but see, so
and
the whole.
The others
so
are solids.
my problem with that was. So
it says mixture, so it's going to be a liquid.
Actually, no. Actually, the definition actually turned out it could be a powder too, which defeats the purpose.
Powder is kind of powder is one of those where it's like it has the properties of a liquid because it fills the container,
right?
But it's not really a liquid. It's a solid. It's a solid physically, but it's like a liquid because it fills the container.
They said a mixture can be at any state: solid, liquid, gas, powder.
Oh, so powder is a new state of element?
No, but they're just
a new state of matter?
they're just saying that as in to not confuse people, just to make sure that people understand that a powder is not a state of matter, but if you have something with a powder in it, you need to understand. And I'm like, what a fucking stupid question, because what is stupid answers? Because none of those, in my understanding of when I was taught what a homogeneous mixture was, and maybe I misunderstand it, when I was taught a homogeneous mixture, I was under the impression that you could not separate the ingredients through decanting. You couldn't just let it settle out.
Is that if that's the definition, then I don't know.
That's what I thought the definition was, but apparently that's not the case because water is a mixture. How is that a mixture though? A mixture had to be two different substances.
It is.
But water is not.
Hydrogen and oxygen.
What? But they're bonded together. That's a compound. That's why I had such an issue with that. It's not like it's...
Well, see, when I think of homogeneous, I just think that all the compounds are the same.
See? And therein lies the issue. So they must have either changed the definition or I must have misunderstood what the definition of homogeneous mixture was. Because maybe I'm just thinking in the terms of mixture has to be two separate things that are not bonded together. It has to be that. But apparently, a mixture can just be fucking water. Just plain, pure water. I don't know how, I don't know why, but it is somehow. I don't understand how, but that's not for me to decide. That's for somebody higher up than me. But now, if somebody, right? Let's say you had a different. Let's say you had a different question where it was like, please identify the element, mixture, compound, and you had salt, water, iron. Not salt. Sorry. What's a good mixture? Brass. Okay. You had iron, brass, water. Under your previous definition, two of those are mixtures. There is no compound there.
Yes, two of them are mixtures, yes.
But that doesn't, but water isn't a mixture. H2O is a compound.
So it says a homogeneous mixture is a gaseous, liquid, or solid mixture that has, they can't use mixture in the definition, whatever.
But there lies the other issue. Or
solid, they're using mixture in the definition. Yeah. I'm going to continue reading, but gaseous, liquid, or solid mixture that has the same proportions of its components throughout a given sample. So basically, if you zoom in, there could be a part of a saltwater mixture that has no salt bonded to the water.
No. Right?
Isn't that what that means?
No. So under this, so water can be both in this case. I think it's kind of like a square and a rectangle almost. Okay?
Yeah.
Water alone can be a homogeneous mixture, but water cannot be a mixture. It can be a homogeneous mixture under that definition, but it cannot be a mixture. Because a mixture, unless a mixture now means that the components can be bonded, I don't know. That doesn't make any sense. Because then what the hell's a...
Yeah, because then when you look at mixture...
But if a mixture can be a solid, then this doesn't make any... That doesn't make any sense!
They use mixture in the definition. It's a process of mixing or being mixed. I guess you don't mix water.
No, you don't! It's a compound! It's a pure substance! It's a
mixture composed of two or more simpler substances in chemistry. Such materials can be compounds or chemical elements.
Okay. What? Oh, components.
Uh-huh.
Okay. That I can agree with.
So it's both. It's a mixture and a homogeneous mixture. A homogeneous mixture is because there's two types of mixtures, right? There's homogeneous mixtures and heterogeneous mixtures.
Right. No one gives two shits. If you're making a mixture, no one's fucking making unless we're talking food. Very rarely do you have a heterogeneous mixture.
Examples are blood, soil, cereal and milk, and ice and soda.
Of mixtures. I was thinking they were giving me heterogeneous mixtures.
That is heterogeneous. Heterogeneous examples. Oh, they also have wine, air, steel, ring.
What's their examples of homogeneous mixtures then?
No, wait, no, this has it backwards then. Because now it says homogeneous is cereal.
Oh, what in fucking Christ. This is the same crap the freaking assignment was getting wrong. If we go by what I was taught, a homogeneous mixture is something that can't be separated through decanting. You can't just let the liquid, you can't just let the solids settle out from the liquids, or you can't just pick it out easily, like a salad. Salad, you can't let it sit, but you can pick out the individual components. Say, cereal, if the cereal wouldn't destroy itself, the actual grain itself. It didn't destroy itself in the milk. Then, yeah. And then milk, if it's been homogenized, homogenized, is a homogeneous mixture. If it hasn't been, then it's a heterogeneous. But the resulting compounds left over are then two homogeneous mixtures because you can't just decant those anymore. You could the cream you probably could. You could probably still the cream you could probably that's just the whatever. Anyways, with a centrifuge, but anyways, it like I said, it was dumb. I'm just like, how in the fuck? Who came up with this? Who here decided?
This is interesting because one of them says steel is a heterogeneous,
and then somebody.
And the other says it's homogeneous.
They don't have a consistent definition because they fucked up.
Interesting.
So that's. I looked at her. I'm just like, I feel bad for you. I felt bad for her for that question. I was just like, I can't help you with that. I don't on the test if he gives you water and steel as two options on there.
Yeah,
Yes,
you're fucked.
You're fucked. I don't know what to tell you.
Fucked.
I'd pick the steel, personally, but apparently, according to your homework, they're both right and both wrong at the same time. So I don't know what to tell you. They don't have a textbook.
I don't know. Looking it up, I don't know. I just typed "is steel a homogeneous mixture?" This says it is. It is made from iron and carbon. A pure substance is different from a homogeneous mixture.
Right.
Because pure only has one component.
Which would be water.
No, it has two.
But see, that's my issue. Where do they draw the line? Do they draw the line at the individual?
At an element.
Okay, they draw at the element. Which then what the fuck? So the term compound is bullshit then.
Yeah, compound, mixture, same thing.
Apparently they're the fucking same thing, according to that definition. Which. You can't teach kids that. I was taught they were two different things because he was then.
So what were you taught? Mixture. So wait. So what's the difference between a compound and a mixture?
According to them, there is no fucking difference.
No, what were you told the difference was?
The difference was a compound had to be broken down via chemical means.
Oh.
A mixture could be done separated mechanically or by, some mixtures you can't separate mechanically. That would be a homogeneous mixture. And homogeneous mixtures, you have to do other processes to them. But they're not bonded together. That was the difference. A mixture is a combination of things that aren't bonded together. And the difference between homogeneous and heterogeneous was heterogeneous could be separated through mechanical means. That's what I was taught. Those are much better definitions. Because it draws lines between mixture, compound, and then draws lines between heterogeneous and homogeneous. According to these definitions, there are no lines. They just draw squiggles wherever they want. I could probably. I have a chemistry textbook. I wonder what it says.
Yeah, look it up.
All right, folks, be right back. This is not a college textbook, by the way. This is an actual high school chemistry textbook. Don't ask how I got it. It's a whole story. Problem is, I don't know where to frickin' start. Atomic massive elements.
Yeah, no, this stuff.
Oh yeah. Let's also. I should also point out this is the chemistry textbook that doesn't just have a periodic table in it. It doesn't. Like most textbooks, the last page would be a periodic table. Nope, it's this. It's atomic masses of elements. It's a periodic table, but in like just list form, which is not useful at all. So, it's not even listed in order. Actually, it's listed in alphabetical order. That's probably why she never picked this textbook. Because
Yeah, no, this says water is not a mixture. Therefore, how can it be a homogeneous mixture?
it can't be. Okay, let's mixture.
Wait, but you said her teacher said it was a mixture?
According to her homework, that was the only option. Unless it was salt.
But how do you know salt wasn't the answer?
I don't know.
Maybe salt water was the answer.
But no, it wasn't salt water. It was salt. Just salt. Sodium chloride. It fucking makes
Well,
sense.
those are still chemically, those are still a compound though.
I don't know, Phil. I don't know. The only reason why I figured out it was water is because of the stupid website you found that said water was a mixture. And then
So you looked it up too?
yeah, and so I said water, but it didn't make any. None of those made sense to me.
Wait, so what were the other two options?
Like elements.
Oh. But yeah, salt. How is that a mixture?
Okay. All right. Well, it could be in different places. So let's try 58 through 60. I think that will be the best bet. 58 and 60. Perfect. Okay, classifying matter according to its composition, elements, compounds, and mixtures. In addition to classifying matter according to its state, we can classify it according to its composition. This diagram. This fucking diagram literally just said exactly what I said.
Show it to the camera.
So this diagram, this one here, can you see that?
Here, bring it a little closer. I'll just take a screenshot and then look at it.
You won't be able to read it, I don't think.
Well, I just took a screenshot. Maybe I can zoom in or something.
Okay. So it starts off with matter, and it has pure substance and mixture. So pure substances, on the left, we have elements and compounds.
Okay.
Under mixtures, we have homogeneous and heterogeneous.
Okay.
Classification, matter can be a pure substance. A pure substance may either be an element, such as copper, or a compound, such as sugar. A mixture may be either homogeneous, such as sweetened tea, or heterogeneous, such as hydrocarbon and water. Water is a pure substance composed of only molecules.
Oh. So I was wrong.
Fuck that teacher.
So that I was wrong and that website was wrong.
Yep. Fucking just. I knew I was fucking right. God.
So water is a pure Well, that's your textbook. So what about all these other websites I'm reading?
I don't know. This is a high school textbook. Now, granted, it's not the world's greatest high school textbook. This wasn't the one we used. Ours had a periodic table in it. This one doesn't have one.
So water is a pure substance.
Yep. Let's read let's read this. Pure substances are comprised of only one type of atom or molecule. Helium and water are both pure substances. The atoms that compose helium are all helium atoms, and the molecules that comprise water are all water. The molecules that comprise water are all water molecules. No other atoms or molecules are mixed in. Pure substances can themselves be divided into two types, elements and compounds. Copper is an example of an element, a substance that cannot be broken down into simpler substances. The graphite in pencils is also an element. Carbon No chemical transformation can decompose graphite into simpler substances. It is pure carbon. All known elements are listed in the periodic table inside the front cover of this book. Oh, that's right. It's on the front cover. Oh, but it doesn't give you atomic mass. No, yes it does. No, what? It wasn't. Why did I say I couldn't find a periodic table? This is clearly... Oh, because it's not labeled very well. It's the most basic periodic table ever. It doesn't give you states of matter. It doesn't label... It labels them into either a metal, metalloid, and non-metal.
What was the difference between a molecule and a compound?
We haven't... The same thing.
There is no difference? They use them interchangeably?
Yes. We're getting there. All known elements are listed in the periodic table in the front cover of this book and in an alphabetical order on the inside back cover of this book. A pure substance can also be a compound, a substance comprised of two or more elements in fixed, defined proportions. Compounds are more common than pure elements because most elements are chemically reactive and combine with other elements to form compounds. Water, table salt. Fuck that question. It literally had water and fucking salt as two of the options.
For what?
Her question had water and salt as two of the questions.
Say that sentence again.
Compounds are more common than pure elements because most elements are chemically reactive and combine with other elements to form compounds. At least on Earth, anyways. Mm-hmm. I would add that. I don't know in space if that's entirely true. I'm sure it still is, but water, table salt, and sugar are examples of compounds. They can all be decomposed into simpler substances. If you heat sugar over a pan, over a flame, you decompose it into several substances, including carbon. An element, a carbon element, and gaseous water, a different compound. The black substance left in your pan after burning contains carbon. The water escapes in the air as steam. The majority of matter that we encounter is in the form of mixtures. Apple juice, a flame, a flame.
A flame?
Yeah.
Oh, hold up, a flame?
Yeah. Because air's a mixture, and a flame is just a plasma of air. Not to mention you have all of your resultants from your combustion reaction, your carbon, your water. So interesting. I guess it's true.
It makes sense. I guess.
A regular flame is a mixture. A regular flame. Now, granted, you could make a flame that's no, that wouldn't be a flame anymore. It would just be plasma, so I guess. Anyways, salad dressing and soil are all examples of mixtures. They each contain several substances mixed together in proportions that vary from one sample to another. Other common mixtures include air, seawater, and brass. Oh, there we go. Air is a mixture comprised primarily of nitrogen and oxygen gas.
Brass is a mixture.
Yeah, brass is a mixture. It's not a compound. Why?
They're bonded together?
No, they're not. Very few alloys are actually bonded together.
Really?
Yeah. Like, I think an amalgam is if they're bonded.
Amalgam?
Yeah, there's an amalgam and an alloy. They're two different things.
So very few compounds are actually...
Oh, sorry. Amalgam is specifically a alloy of mercury.
Oh.
Amalgam is specifically any alloy of mercury with another metal.
Oh. Well, then what's the other word?
Alloys.
No, but you said alloys and something else. Is there another word instead of amalgam that you meant?
Possibly. Metallic substance comprised of two or more elements as either a compound. An alloy can be in a compound or a solution. Yeah.
Wait, so brass is not a compound?
No. Truth be told, I'm sure there are some steels that are compounds and some steels that aren't. Probably. I shouldn't.
Mm-hmm.
I don't know that for certain. But metallurgy is, let's put this lightly here, complicated. Very complicated. On the surface, you're just mixing, two substances together in a hot furnace to see what the hell happens. But in reality, it's much more complicated. That's why I love material science. It's there's so much bullshit. Anyways, I'm sure you could find a chart somewhere, a little flow chart that describes all this quite eloquently.